Good afternoon, everybody. My name is Ned Cake. Here to introduce Dan Thomas. Dan is on staff here at Tallahassee, Leon County GIS with me. He's one of the smartest people I know. And on staff, he's commonly known as my spiritual advisor. He sort of keeps me on the rails. On top of that, he's one of the best staff members we have. Anyway, I'll ask you to hold your questions to the end, type them into the question box, and without further ado, I'll get things going. Hang on just a second. Let me let Dan share.
Thank you, sir.
Let me find Dan here in attendees. This might take me a second. Haven't presented, oh, staff, there we go. And make presenter. There you go, Dan, it's all you.
Thank you, sir. Okay. That's showing correctly?
Yes, it is.
All right, great. Well, Shrug this year has been very interesting, and I'd like to thank Shrug for the opportunity to present. And it's been a great and interesting Shrug, and I'm kind of glad I get to go last because it's been some interesting presentations ahead of me that kind of funneling you down to where I'm at. From Adam, I realized that your GIS needs to be aligned. And from Will's presentation, ArcGIS Enterprise is foundational to your organization, Web GIS. So you're sitting here as an organization, you're doing strategic planning, and you realize that you might want to consider deploying Enterprise as a solution into your organization. So you need to go through some process, and you need to probably do a discovery on Enterprise as a technology, but you also need to do what Buddha would describe as a view of oneself as well before you make this decision. So knowing when your organization is ready for ArcGIS Enterprise is this discovery, this journey that we are undertaking to come to a final decision of, are we doing Enterprise and how we're doing Enterprise here at TLCGIS. So I consider a lot of decisions like journeys. There's movement, there's a to B, like you make a decision as simple as I want a cup of coffee, done, A to B, you're there. Some decisions is like scaling the base of Mount Everest. It takes a lot of planning and it can be painful to get there. And a lot of things you need to do is questioning your decisions or the journey is, do you understand the people you serve and what their needs are? Also, you need to know, since you're making significant changes in your organization, can your staff or the organization handle that adoption of a technical change of any significance? And also, organizationally, how are you structured? Do you have the right structure in place to absorb this change? So one of the best ways to find out about the view of oneself is to use metrics. The metrics, I believe, are the key to unlocking who you serve, what tasks will be performed, and how long does it take those tasks to get done. And one of the things that it doesn't matter if you're a small one-person GIS shop or 2 to 3 person or a large enterprise shop, you're going to basically have these 3 things you have to contend with on a daily basis. Expectations. Everybody's going to have the high expectations. They're going to want things done. They want you to, be their hero, save them every day. Demand, there's only so much you can do in a day. There's only so many objects you can keep up in the air, plates spinning, balls in the air, whatever. Service level is just the amount that you can just get out. You know, there's only so many hours a day and only so many people to handle tasks or functions or keep the lights on in your enterprise. So having that self-assessment of self and knowing what your customers want, knowing your organization, and knowing what your staff is capable kind of comes into that big picture. You know where you're at. So you kind of, then you can kind of launch off into in a direction of knowing where you want to go. And so some questions that kind of shape that, getting to that destination are the what, where, why, how, and when, but we're going to tackle when at the very last. So we know what we want to do. We want to deploy ArcGIS Enterprise in our organization. The reasons that we discovered, well, we want easier loads of workload shifted between staff and customers. Of course, there's rapid deployment of maps and applications, single sign-on security. You never get over people always asking, I forgot my password, can you help me? So if you can manage just having one password instead of multiple passwords, as we have with having our main presence in ArcGIS Alliance, so that's an extra password besides the security password everybody has in their organization at their desk. That makes life a lot more simple. Plus, also one of the bigger things is that ESRI is coming out with new technology, and is your organization following in that wake, keeping on track? So adopting enterprise is one of the things that move you in that direction. Now the questions come that are left over are the where and the how. So we're going to look at the where. And this is not a shameless plug to ESRI, but one of the simplest way to get off the ground is to use ESRI managed cloud services to do your deployment. And it's not that you know, not capable, but if you have a small staff or no IT resources or not the infrastructure, this is a quick way to get off the ground and serving your customers. This is where the focus becomes mainly you're producing services and you're not wrapped around the axle of trying to handle and manage the technology. You're focused on the task and not the vehicle that's taking you to that end. So again, maybe it's something you discuss among yourselves and get with your ESRI representative if you're interested in doing enterprise. The next where that you could possibly go, you still use the cloud, but you take on the responsibility of building that infrastructure yourself. Again, it's a good choice if you don't have the technical resources in-house or the infrastructure. You can leverage AWS with Amazon, you can leverage Microsoft Azure and Google Cloud. And of course, you still have technical support from ESRI to assist you on those rough points. But here you manage more of the process. But again, you're not stuck with that technical debt of handling the infrastructure. You don't have to worry about patching, backups. All that's handled by your cloud provider. So it's a win-win situation. You get to serve your customers, you get more control of the process, but your focus is just that service end, not the whole picture. Now, the last where is what I call the village method, because it really takes several expertise with in-house to do an on-prem deployment. I mean, you're dealing with network, you're dealing with databases, you're dealing with security, you're dealing with provisioning servers, and then you have the GIS component wrapped around all of that. So that is a big lift, and you really need to have, you know, that village of technical people at your disposal to really make this work successfully. So the where for TLCGIS is to look at, we have that capability in-house. We want to do a self-managed in-house on-prem deployment. So now let's look at the how. So the how kind of centers on the life cycle of hardware and software deployment. And conceptually, there's been 3 ages of software hardware deployment that you can conceptualize. The first is what's considered traditional. It's building a deployment on a physical server that you purchase, either as a tower or a rack mounted server. You put an operating system on it, then you install an application and configure and use it. Now, that I started my IT career where that was still the kind of the norm. It was a time where you had to deal with server sprawl because applications, as they became more plentiful, demand different resources, different things of the operating system. So you couldn't necessarily run multiple applications on the same server. You had to go out and procure another server and load that application in that environment, and that went on and so forth. So server sprawl became a big significant issue. So, and even to this day, at times, depending on the vendor's software requirements, you still might need a physical server. So that hasn't gone away, but the trend more now is to go into virtualization, which really put IT on its head and really propelled it into what a lot of our modern data centers look like. Here, with the introduction of virtualization or running code to simulate a server on a actual physical server, allowed you to carve off little sections of that resource, that main physical resource, into smaller, more manageable virtual machines that you can load applications that play well together. Or if you need to isolate an application by itself, you can dedicate the resource to it. Here, again, you densified your operation, got rid of the server sprawl, and kind of moved into the virtual space where it's more manageable. You have now, because you're provisioning things in a standardized manner, you get things like automatic software deployment, remote management, which made it easier on IT people to manage the infrastructure, and made, you can easily give the keys to people who are technical leads in other areas who are not IT people, management of the software. So you get that collaboration kind of spreading out of IT into other areas. But there again, it still is a big lift because somebody's got to manage the hardware, and also security wise, software patching is nightmarish because now you not only have to manage the lower tier of the physical hardware, you also have to manage the upper tier of keeping all the virtual machines up to date, which can be a big challenge if you have a large organization. And that's the reason why the third age now is container deployment, or sometimes called Kubernetes. Now you're running microservices where the operating systems only add if you choose to have an operating system, because you can run the container on what's known as bare metal. You can have a physical server with nothing but the container portion on it, or you can stack the operating system and a hypervisor in between the container, and you can choose to run this stack however you want to, depends on your organizational choice. But the main thing is your application no longer runs on it runs in a virtual device called a container, but there's no operating system anymore. You just put the pieces and parts together that you need to run that piece of software, and now you're free. You're not locked in to what the operating system on the physical device dictates. You're kind of off doing your own thing in your own space, which has a lot of advantages. It frees up security It makes security a lot easier, flatter. It makes patching definitely easier because you no longer have to worry about your virtual environment as far as patching. You only have to worry where the operating system lives, which is down on the physical device. And as we go forward, you'll see more and more advantages of why container or Kubernetes is now starting to be a consideration. So we're still at this point of how. Well, we're going to do traditional server deployment with Windows or Linux, or we're going to do containers, Kubernetes. And let's kind of dive into a deployment. Let's look at some of the pieces and parts here and try to make some sense of things. So this is a high level build of ArcGIS Enterprise. And on the left, we have, like, I've broken Enterprise into constituent parts. So the top part is the presentation or the portal UI, where it's the gateway where users interact with portal. The second service tiers, where it's basically the engine of your portal, is a ArcGIS server site that's bonded to the portal and the data stores. That's where all of the processing, geocoding, printing is generated and pushed up through the UI of the portal. And the data stores, where you store things when you create feature services in your portal, or you save web maps. That data state is saved in the relational store, and in the, if you make a vector tile map, it's stored in the tile cache. Now, in between, there's a load balancer where you can bring in more functionality from other Arc servers that are outside of your portal. And this is called federating to your portal, where you can have an image server, which introduces the image server's capability. You got mosaics, caches, compact caches, fuse caches, which you can serve into your portal, which fleshes out your content and other capabilities and availabilities inside your portals, like you could do in ArcGIS Line. Also, you have a standard Arc server in the GIS server role, producing map image services and feature services from databases that you have on-prem. So all this collectively makes up your portal system. And I know it looks very simplistic, but this is kind of conceptualized where HA, high availability, on each tier is considered. So let's kind of step back and summarize what it looks like total as a system. So even using VMware, you're looking at a total of 18 servers that need to be deployed to make up that diagram. And at each tier, as you see, there's a CPU cost and a memory cost and a disk space cost. That's a lot of servers to maintain. And also not as just, from a GIS perspective, also from an IT perspective. That means every server's got to get backed up. Every server's got to get its patching done. And if you have configuration issues, where do you start troubleshooting where the problem at? Because you have 18 servers to check and see if there's issues. So, but that's where we live at. That's, we take on the challenge. The cost benefit of being able to serve our users and all the benefits of enterprise are great, but this is the cost of doing it. So Kubernetes is another option, and created by our great and wonderful Google. Initially, Kubernetes is an homage to 7 or 9, if you're sci-fi fans, and Star Trek, Star Wars, you know who 7 and 9 is. And they wanted to call it Project 7, but decided to call it Kubernetes because they came up with a logo that have 7 spokes. The 7 spokes goes to 7 and 9, and Kubernetes is Greek for helmsman or pilot, which makes the wheel a good logo. Also, if you want to abbreviate it, CAKES is because Kubernetes has 8 letters between the K and S. So if you get on Jeopardy and ask you what's the abbreviation for Kubernetes, now you know. So let's look at this diagram that's in the ESRI documentation for Kubernetes. And it doesn't matter if you deploy this on bare metal or virtual servers. And let's introduce some terminology that's going to be important to you. First off, Kubernetes has a cluster, and this is a group of servers that you deploy that are glued together with software to serve this, what is known as a namespace, which is namespace is going to be your site. And your nodes are more like fault clusters inside your site. And you can think of nodes also organized-wise as folders that you would see on the ArcGIS Manager. And underneath each node, there's pods that have specific functions. And a pod is really a collection of containers. It could be one container, it could be several containers underneath each pod. So on the outside, again, like a traditional site, like in my other diagram, you can have other things that are outside of the portal shared into. You can still federate a GIS server or image server. You can still have other data stores outside of the cluster. But then there's specific data stores that have to do with the persistent volume storage. And currently, your choices for doing Kubernetes is you can do it with Amazon, you can do it with Microsoft Azure, or you can do it on-prem with the Red Hat OpenShift container platform. And I point this out again. It's OpenShift container platform. There is so many abbreviations when you go look at Red Hat of just OS, and you think you're looking at the right one. You want to make sure it's the container platform. And coming soon, Google will have a version of Kubernetes that supports ESRI. So I've tried to get someone from ESRI. Most of you know Dave Crosby at the Charlotte office, but unfortunately he's on vacation this week, and he was kind enough to ask around within the organization. Of course, everybody's either tied up with GIS Day elsewhere or on vacation, but he did manage to get me somebody who's quite an expert, Trevor Seaton, who's actually the Kubernetes product manager in Redlands. So I got this great lifeline out to Trevor, and he brought in some good information that we should all consider. So like you said, in the diagram, I forward portions of my presentation. So he's quoting exactly what's in the presentation. So the cluster setup is managed by the customer, and this is similar to whether it's on Windows or Linux. And again, Kubernetes is supported with AWS, Azure, and will be soon on Google. Now the pods are just an ideal of what the architecture looks like. You can say roughly in reality, there's about 40 pods are created and deployed with the software. And you can isolate or dedicate GIS services as needed. It's one of the advantages that came out with the redo of Enterprise at 10.7.1. And the pods can take the place of what you need for high availability. So if you need more lift, you create more pods. Now, one of the key things why Kubernetes is interesting, they say they're lacking the ability to do horizontal auto scaling, but the process in Kubernetes, if you need more lift, you create it within the Kubernetes environment. You don't have to go outside of it like if you have physical servers or even a virtual environment. Now imagine you have an existing system and you want more IO at a tier, like the service tier. If you were doing physical servers, that means you may have to go buy another physical server, bring it in, put it in your environment, go through the process of getting it ready for your environment. Then you still have to load the software. Then you have to do the configuration. Then it's ready to go into your environment and be used. Even virtually, you still have to provision a VM, do all the network connection, do all the work to connect it to disk on your network, load the software, patch the base operating system, then load your GIS software, configure your GIS software, then load it into your site. Again, having the ability to just do it within the environment and not have to go outside of the environment is a big, big change and a big, big plus. So this slide, I hate to say it's the good news, bad news for some folks. If you already have a ArcGIS Enterprise deployment, either at 10.5.1, 10.6.1, 10.7, unfortunately, going to Kubernetes is a bigger lift than what you think it is. There's no way to take that build and roll it into Kubernetes. You would just have to redo it. Good news, if you haven't done Enterprise and you're interested in it, now you start with a clean slate, and you can start without having to deal with ArcMap at all. You can start with just Pro and Kubernetes and go forward. Now, if you have enterprise geodatabases, unfortunately, you have to have it at least the 10.9 level. Now, according to Will, the 10.9.1 level version is soon to be available. So you want to start at least at the base level, or at least one above the base level. And anything that you've done with GIS servers and ArcMap, you're going to have to take those services and redo those in Kubernetes. But again, it's a different build, different version or mindset of how to do things. So, you know, that's just the luck of the draw. And it's still, I think it's still worth it. So if you're doing on-prem, your choices, again, are doing Red Hat OpenShift container platform. And again, you can do it on physical, on a virtual environment, build your own private cloud, or use a public cloud. And that way you can do container as a service, which is CAS, to a platform as a service, PaaS, or functions as a service, or FaaS. And it's easier to, like I said, to deploy, update, because you're doing everything within the environment. And on the right is an example of what OpenShift container platform looks like within VMware. It's still, I know it's high level, but it relates to the first diagram I showed, where you have your nodes and you have your controllers that have certain functions, and you have your worker nodes, which are the software components that run your microservices. And it's all managed through an Ansible automated host to do some of the tasks. And you can have other servers as well. So taking the documentation of Red Hat OpenShift container and with VMware in the mix, and taking the documentation of what a enhanced availability for ArcGIS Enterprise and Kubernetes, you come up with these totals. So in the documentation, they have 31 pods, but according to Trevor, when they deploy the software, you can have at least as many as 40. So I went with that number since he sees the software more than I do. And you think, wow, this is a lot of resource just to build this. But again, think of, you need this extra resource to do that easy replacement, easy scalability. So it is the juice worth the squeeze, as we say here. potentially, and we're still evaluating that. So again, asking our geo expert, what are some of the future things for Kubernetes? Well, they're looking at adding web adapters, which is one thing that was missing. They're going to make some administrative things easier when it comes to backup and restores and security encryptions. They realize that there's other flavors of Kubernetes supported on other platforms like Tanzu, which is a VMware-based Kubernetes, and Rancher, which is another open source one. They're not there with those flavors yet, but they're probably under consideration. Unfortunately, because Kubernetes is a new deployment for enterprise, you don't have the other capabilities of Geo Event Server or Geo Analytics Server available, or Notebook, but that's soon to come. And not to kind of dispel some of the confusion, on-premise is also private cloud. But and if there's something that's not mentioned here that you guys are considering, or are Kubernetes, use another Kubernetes flavor, please let ESRI know they're interested in knowing what's out here and like to try to bring it under the fold. And I also like to again thank Trevor and David Crosby for adding this very important content to the presentation. So we're at the win. We kind of covered why we want to do it, how we might want to do it, and where we might want to do it. So when are we going to do it? But there's other factors that kind of hinge on when. You have to have the budgeting in place. Then you have to go through the purchase process. Then is the technology ready? If you choose to go Kubernetes, is it ready enough for you, or are you going to go traditional? And again, can your team absorb that big impact into your organization? And then is your team ready? Are your team tied up with other projects, or you depending on other resources in the organization, are they available? So timing is always a critical component on either end of budgeting, purchasing process, or building the technology and having the team to work on the project. So if you're interested in Kubernetes, I suggest, especially if you're interested in doing an on-prem or a cloud implementation of it, here's where you can start gathering some information. You definitely want to create an account with Red Hat and dive into the documentation. There's other ways to deploy Red Hat, OpenShift on various platforms. So you're not tied to just the main thing is one of the requirements of Kubernetes with the ESRI that has to be an x86, x64 based platform, but there's other flavors that you can add to. You can do Linux, you can do, I believe Red Hat has its own virtualization that you can have OpenShift on top of. And also you definitely want to refer to the ArcGIS Enterprise Kubernetes documentation as you craft which way you want to go with your potential deployment. And with that, we're opening everything up for Q&A. So Ned, take it away, sir.
Thanks, Dan. That was fantastic. So if you have questions of Dan, go ahead and type them in the question box, and I will read them out to him so we can answer them. Will Myers says, nice job, Dan.
Thank you, Will.
Can you tell us why high availability is important?
Definitely. If you do a base deployment of enterprise, which basically is roughly 5 servers. If you have a need to lift beyond that system, you're going to have a failure either at the service level tier where your Arc server is just so pegged out it can't respond to what the requests are being driven. And that can even happen even if you have multiple machines in your deployment. Had that happen when something went viral in a 6 server tiered site running multiple machines where all 6 servers were so pegged it couldn't respond to the demand of one service.
That's a Hurricane Michael flashback. Hurricane
Hermine
flashback.
Hermine. So yes. You want to, anything you build, you want to have redundancy. The extra costs, because again, you don't want to drive your car without a spare. You don't want to run any mission critical software without having some HA in the mix. Good question.
What case uses is TLCGIS considered for enterprise and portal, enterprise/portal?
Again, it's like I said, it's where ArcGIS Enterprise is going. One, since we support utilities, one of the major thing is utility network, or UN, and that's a whole topic unto itself because it replaces the geometric network base management of data that's under ArcMap into the ArcPro version. Other sectors are under considerations: public safety and property appraiser with parcel fabric using Pro instead of ArcMap.
So for TLCGIS, that means it's going to happen. It's just how do we do it, and that's where we are right now is making decisions.
Exactly.
The entire first portion of your talk.
Exactly. Doing the self journey, knowing the view of oneself and knowing what you're doing with your interlocal or your support group.
And whatever you build has to be able to accommodate a NED load of layers. So
of course,
good luck with that. Anybody else with some questions? I think that's all we have, Dan. I want to thank you for taking the time out to prepare this presentation and present it. It was excellent. Good work.
Thank you, sir.